In this video, we'll break down how to build your own private large language model in a simple, step-by-step way. We'll cover what LLMs are, how data is prepared, what happens during training, and how to evaluate the final model. And yes, there will be quick quizzes in between, so you can test your understanding as we go. Large language models are becoming a major part of modern AI. They help with content generation, question answering, translation, coding, and much more. But many organizations now want private LLMs because they offer better control over data, stronger privacy, and the ability to customize the model for specific business needs. An LLM is an AI system trained on huge amounts of text, so it can understand and generate language in a human-like way. Most modern LLMs use transformer-based neural networks. After training, they can answer questions, write content, summarize text, translate languages, and even hold conversations. The first real building block of an LLM is data. Strong models are trained on massive and diverse data sets, including web text, code, books, academic content, and legal or domain-specific records. If you're building a private LLM, your own internal data can become a big advantage, but the data must be accurate, diverse, clean, and privacy-safe. Now let us look at this in a simple table format. LLM types. 3 common approaches used in language modeling. Not all LLMs work in exactly the same way. Autoregressive models predict the next word and are great for generation. Autoencoding models focus more on understanding and reconstructing text, so they are useful for analysis tasks. Hybrid models combine both strengths, making them flexible for complex applications. Now that we've covered LLM basics, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. Why are many companies interested in private LLMs? The correct answer is, they offer more control and privacy. Private LLMs are valued because organizations can customize them, protect sensitive data, and reduce dependence on external providers. Question 2. Which type of LLM is best suited for text generation? The correct answer is autoregressive. Autoregressive models predict the next word based on previous words, which makes them ideal for generation tasks. Question 3. Which of the following is a key quality of good LLM training data? The correct answer is clean and diverse. High-quality LLM data should be clean, diverse, accurate, and suitable for the model's purpose. After collecting data, you need to prepare it for learning. Tokenization breaks text into smaller units the model can process. Embeddings convert those units into numerical vectors, so the model can capture meaning. Attention then helps the model focus on the most relevant parts of a sentence or context while making predictions. Think of embeddings as turning language into math, while preserving meaning. Similar ideas get mapped closer together in vector space. Attention adds another layer by helping the model decide which words matter most in a sentence. This is very important when the same sentence contains multiple signals, like product quality and service feedback together. Now comes the training pipeline. First, data is collected and loaded. Then it is cleaned, normalized, and checked for consistency. Large documents are split into manageable chunks while keeping context intact. After tokenization, the data is loaded in batches, often with shuffling and parallel loading, so training becomes efficient and stable. During training, the model makes predictions and compares them with the expected output. The difference becomes the loss value. Lower loss usually means the model is learning better. Training happens in iterations, where one batch is processed at a time, and in epochs, where the model sees the entire dataset once. Monitoring these values helps you improve performance and avoid overfitting. Now that we've covered training flow, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. What does tokenization do? The correct answer is breaks text into smaller units. Tokenization converts raw text into smaller pieces, such as words, characters, or subwords, so the model can process it. Question 2. What is the main purpose of embeddings? The correct answer is to convert text into numerical vectors. Embeddings represent text as vectors that capture semantic meaning and relationships. Question 3. What does a lower loss usually indicate? The correct answer is better alignment with targets. Loss measures error, so lower loss generally means the model's predictions are closer to the expected outputs. Hyperparameter tuning can make or break training. The learning rate controls how big each weight update is. If it is too high, training may become unstable. If it is too low, learning becomes very slow. Batch size also matters. Larger batches are often more stable but need more memory, while smaller batches are lighter but noisier. Training an LLM is not just about algorithms. It is also about compute. Data parallelization splits batches across multiple GPUs. Model parallelization splits the model itself when it is too large for one device. Techniques like gradient checkpointing help reduce memory usage by storing fewer intermediate values during training. Once training is done, evaluation becomes critical. Common benchmarks include MMLU for reasoning and understanding, GPQA for broad question answering, math for mathematical reasoning, and human-eval for coding ability. But if your LLM is built for a specific use case, like healthcare or legal work, your evaluation metrics should match that real-world objective too. Now that we've covered tuning and evaluation, let's test what we've learned so far.
Here's quiz number 3. See if you can get it right.
Question 1. What can happen if the learning rate is too high? The correct answer is training becomes unstable. A very high learning rate can cause large, erratic updates and prevent the model from converging properly. Question 2. Which technique helps reduce memory usage during training? The correct answer is gradient checkpointing. Gradient checkpointing saves memory by storing fewer intermediate activations and recomputing some values when needed. Question 3. Which benchmark is commonly used to test coding ability? The correct answer is human eval. Human eval is widely used to assess whether a model can generate correct and functional code. Building a private LLM is definitely challenging, but it can be incredibly rewarding. With the right data, pipeline tuning, and evaluation strategy, you can create a model that is secure, customized, and genuinely useful for your domain. If this walkthrough helped you, use the quiz answers to revise once more and keep exploring the LLM journey.